Assalamualaikum and good evening. We are from Group 3. We present the experiment 1, which is the Marchett boiler. When water is heated, water molecule will gain the kinetic energy. The more they are heated, kinetic energy increases and water molecule will vibrate faster. Eventually, water molecule will gain kinetic energy greater enough to break from the surface of the water by breaking the intermolecular forces such as hydrogen bond and become steam until it reaches equilibrium between water and vapor state. The state of equilibrium depends on the pressure in the surface of the water. Boiling point increase as pressure increase. At higher pressure, there is higher resistance for water molecule to diffuse from liquid phase to vapor phase. Thus, boiling point of water increases. This is because the molecules in the liquid phase are arranged more tightly and packed together. More energy required to break the intermolecular forces that holding the molecules together. The pressure of a given amount of gas is directly proportional to its absolute temperature. Marchett boiler has been developed for investigating the relationship between the pressure and temperature of saturated steam in equilibrium with water at all pressure between atmospheric and 10 bar. The measured value of the slope of graph, which is dt over dp saturated, obtained from the practical results can be compared with the corresponding values calculated from the data in the steam table. The objective of this experiment is to observe the relationship between the pressure and temperature for the saturated steam. There are three scopes for this experiment. The first one is the coverage of this study is the increase in temperature for every pressure increase of 0.5 bar until the pressure reaches 5 bar when heated. Second, the study consists of the temperature decrease when temperature is recorded for the pressure decrease of every 0.5 bar after the heater was switched off. Third, the study only covers the substance used, which is the distilled water.
Next, I will talk about theory and working principles. Thermodynamics deals with energy which has ability to cause change when energy is transferred from one form to another form. The properties of the change can be determined by using two of these properties, whether it's temperature, pressure, entropy, specific volume, enthalpy, or etc. The two thermodynamic properties that are easily measured, especially for this experiment, is temperature and pressure. One of the equations that shows temperature and pressure relation is Clapeyron equation, where differentiation of saturated temperature and pressure is equals to temperature times volume of steam minus water divided by enthalpy of water minus steam. Clapeyron equation determines the equilibrium between two phases of a substance. It determines the saturation vapor pressure for water. This condition occurs when no additional liquid water is evaporated. It becomes equilibrium between vaporization of liquid water and condensation of vapor. Temperature at which substance change phase is called saturated temperature. Pressure at which substance change phase is called saturated pressure. Pressure of steam is directly proportional to its absolute temperature.
For the experiment setup. So here we have MOSFET boiler. So in MOSFET boiler we have manometer, a main switch, heater switch, a temperature sensor, a safety valve, filler plug, overflow valve, heater, and a drain valve. Next will be the methodology. So for the first step, a spanner is used to easily open the filter and the overflow valve. Then the MOSFET boiler is filled with distilled water until the distilled water are overflow through the overflow valve. The next step will be the filter plug is closed. Use spanner is used to easily close the valve. Next will be the main switch and the heater switch is turned on. The fifth step is to the overflow valve is closed once the temperature has reached 97 degrees Celsius. The sixth step will be each temperature reading. Uh, When 0.5 bar increases is recorded until the pressure reaches 5 bar. The seventh step is after reaching 5 bar of pressure, the heater switch is turned off. Then record the temperature reading when the pressure drops by each 0.5 bar until it decreases to 0.5 bar. Last step is to turn off the main switch and power switch after using the master boiler.
Result and discussion. Absolute pressure equals to 1 plus gas pressure. Temperature in Kelvin equals to 273.15 plus temperature in degrees Celsius. 1 absolute bar equals to 100 kilopascal. Table 1 shows the result of gas pressure, absolute pressure, steam temperature in increasing pressure, decreasing pressure, and mean, measured slope and calculated slope. This is example calculation of gas pressure equals to 0.5 bar gauge. Gas pressure equals to 0.5 bar gauge. Absolute pressure equals to 1 plus 0.5 equals to 1.5 bar absolute. The temperature mean is the steam temperature in increasing pressure plus steam temperature in decreasing pressure divided by 2 equals to 109.55 degrees Celsius, and convert it to Kelvin is 382.7 Kelvin. In 1.5 bar absolute, the difference in temperature is the average temperature in 2.0 bar absolute minus average temperature in 1.5 bar absolute equals to 8.85 Kelvin. In difference in the pressure is equals to the absolute pressure in 2.0 bar absolute minus absolute pressure in 1.5 bar absolute equals to 0.5 bar absolute, and convert it to kilopascal is 50 kilopascal. The measured slope is the difference in temperature divided by the difference in pressure, which is 0.177 Kelvin per kilopascal. Interpolation of Vg and HFG value based on the 1.5 bar absolute pressure by using the table 2. We can see the 1.5 bar absolute is in the between of 1.0 and 2.0. So volume of steam Vg equals to 1.5 bar minus 1.0 bar times with 0.8856 minus 1.694 divided by 2.0 minus 1.0 bar plus 1.694 equals to 1.2898 meter cube per kg. Heat domain of vaporization HFG equals to 1.5 minus 1.0 bar times 2202 minus 2258 divided by 2.0 minus 1.0 plus 2258 equals to 2230 kilojoule per kg. The calculated slope equals to the temperature mean times with the volume of steam Vg divided by heat domain of vaporization HFG, and we'll get 0.2213 Kelvin per kilopascal. The same step and stem method also apply at the gas pressure equals to 1.0 bar gauge. Only the volume of steam and heat domain of vaporization no need apply the interpolation method. So at 2.0 bar absolute, the Vg can directly take from the table 2, which is 0.8856 meter cube per kg, and HFG equals to 2202 kilojoule per kg, and the calculated slope is the same as the mean temperature time with the Vg and HFG equals to 0.1575. Graph 1 shows graph of absolute pressure versus steam temperature in increasing pressure. The slope of graph 1 is 0.0994. Graph 2 shows graph of absolute pressure versus steam temperature in decreasing pressure. The slope of graph 2 is 0.0985. Observation during heating process is pressure gauge show pressure value increases and temperature value increases until pressure reach 5 bar. Observation during cooling process is pressure gauge show pressure value decreases below 5 bar and temperature value decreases. Graph 1 and Graph 2 show the relation between absolute pressure and the saturated steam temperature for heating process and cooling process. For the heating process based on the Graph 1 plotted, it produces an increasing curve. It shows the absolute pressure increases and nearly become linear as temperature increases. For the cooling process based on the Graph 2 plotted, it shows a decreasing curve in the graph of cooling process. As the absolute pressure decreases, the steam temperature decreases. Before the experiment starts, initial pressure is zero while temperature of the water is at room temperature. As the heating process was conducted, the pressure increased proportional to the increasing temperature. This is due to pressure and temperature depend on each other. They have a direct proportional relationship. Ideal gas law, PV equals to nRT. In this experiment, number of mole, volume, and R is constant. Gay-Lussac's law is a gas law which states that the pressure exerted by a gas is directly proportional to the absolute pressure of the gas when the mass is fixed and kept at constant volume. When the water in the boiler is heated, pressure exerted by the steam inside the boiler increases. In both graph 1 and graph 2, the curve shape of the graph for cooling process is almost equal to shape of the graph for heating process because the decreasing rate of the temperature during the cooling process is almost the same as the increasing rate of temperature during the heating process. However, cooling process needed more time as water cooling down slower than the time needed to heat it up. This is due to the difference between the surrounding temperature and the water was very large. Overall, there's a slightly deviation between the measured slope and the calculated slope as the theoretical value is taken from the table saturated water and steam. Some of the errors also might occur during the experiment that can affect the accuracy of the result. Parallax error where the readings were taken when eyes are not positioned perpendicular to the measurements marking, which cause inaccurate reading of gas pressure.
Okay, for the conclusion, as a conclusion, temperature is directly proportional to pressure. Graph shows temperature increase and decrease linearly with pressure. Plotted graph is a curve, even though the slopes of the graph are slightly different from the theoretical value. This difference is due to an error that happened during the experiment. Furthermore, this experiment can be considered a success since the data we have is almost identical to that found in the steam table. Air must be completely removed from valve by closing the overflow valve when the temperature reach about 97 degrees Celsius to 100 degrees Celsius to avoid inaccuracy in reading. Okay, for the safety and laboratory procedure, for laboratory safety, first, wear appropriate personal protective equipment, including lab coats, gloves, and closed-toe shoes to protect against hazardous material like hot water or hot surface might burn our skin. tie back long hair and avoid wearing loose clothing and jewelry that could cause in equipment. For precaution steps, take the measurement reading with your eyes perpendicular to the pressure gauge to minimize parallax error. Be cautious when dealing with high temperature surfaces. Conduct the experiment carefully to prevent any errors and injury. Reference. This is the reference that we study to make our report. That's all from us. Thank you very much.